Okay, here we are. We're back, and we're going to take a look at this second video on torques. In the last video, we defined what a torque was. We stated that a torque is nothing more than either an Fr, and that's assuming that the force is perpendicular to the beam, or if the force is at an angle, we would just write a sine theta r in there, and that would take into account the angle in the beam. So that's basically where we're at right now. So how do we do torques where we're like in this one, where you can see there's 1, 2, 3, 4 different points where forces are acting. Now here's a point down here that's got two forces acting on the same point. But let's go through and do this. First of all, probably one of the most important things is this. Let us pick a pivot point. Let us pick a pivot point. Now, a lot of times in the first problems, they will tell you a pivot point to pick. Get ready for a bunch of P's being twisted up in this one. So they will tell you the pivot point. Well, in the case of this picture right here, I'm going to do this. I want to go through and try it a few different ways. I want to try picking A to be my pivot point, then maybe B, or this point where C, or maybe where D and E is over here. I want to try a few different places of choosing pivot points. Because here's the reality. When you go to do this problem and you're all by yourself, if it doesn't tell you where to pick to be your pivot point, you get to choose where your pivot point is. In other words, you can just go in and randomly say, I declare the point where A is to be my pivot point in the case of this problem. Or I declare that the point where this is to be my pivot point in this problem over here. So anyway, it's got you a little idea. Now, before we can really proceed with trying to do all this, we really need some links in this problem. I'm going to see if I can do this and not make a mess of the problem. Let's say that these two objects, these two forces, how far do you want to say? Let's say those are 1 meter. I like keeping fairly simple numbers here. Well, I hate to say it in the event of my drawing. My drawing's pretty even. Let's say that right here is also 1 meter. And I really hate to say it, but let's say that this is also, you guessed it, let's say 1 meter. Let's say it's 1 meter between every one of these in this picture right here. So when we go to work it out. Well, let's do this. I got an idea. Let's start over here. Let's make this our first pivot point. Now, this is where some people start having a hard time. And normally I like to circle my pivot point, but I don't want to wreck this sheet of paper, so I'm just going to stick my finger right here. So that is my pivot point. So what I want to do now is write an FR equation for every one of these. Now, here's the thing. I'm not going to write an FR for the pivot point. Why not? Well, the pivot point I'm defining wherever the pivot point is. Here, I'll write that down. Where the pivot point is, my R is 0, which means I don't have any torques at the pivot point. So I have just canceled out both D and E from this entire problem. They gone. So I'm going to put my finger here. I'm going to declare you to be my pivot point. Now, I do got one little thing I need to do. I need to group these torques together. So I need to identify my torques that are, I'm going to write CW, my clockwise torques, and then what I'm going to do is this. Then I'm going to subtract all the torques that are, well, counterclockwise, and then I'm going to subtract the counterclockwise. And some teachers might teach it different. It's all in whoever's trying to do it. But what I'm going to do is this. I'm going to go through this question, and I'm going to write down an FR for all my clockwise. What do I mean clockwise? Well, believe it or not, I've found that students over the years have the worst problems with trying to do this. Well, it's a very flashy ruler. It's kind of like blinding with this light over my head. But anyway, here's what they do. They get confused. They don't know if something's clockwise or counterclockwise. So I'm going to stick my finger here so that this ruler can rotate. Well, now what I'm going to do is this. There's A, so I'm going to push. Which direction does this rotate when I push at point A? So push at point A. Well, this is clockwise. So, all right, now we're getting somewhere. So this A is a clockwise torque. So that one's clockwise. Let's take a look. We'll go back, put my finger down for my pivot point, and here's C right here. So what happens if I push right here? Well, if I push at C, you can see once again, which direction am I rotating? At point C, if I push, well, it looks to me like I'm rotating clockwise again. So C is a clockwise torque. Well, you should be able to start guessing about this force. Put my finger back down right here. Now I'm going to push at point B. I'll use my thumb. Push. Which direction is my... And y'all, I did this in college. I'd get a ruler out or my pencil and start pushing. Push. And you can see that's counterclockwise. So now I'm going to start kind of CCW. I like knowing this is a clockwise, that's a clockwise, that's a counterclockwise. Based upon that pivot point. All of it will change if I pick another pivot point. But I'm picking this guy to be my pivot point. Not because it's on the end, but just out of pure whimsy am I picking that to be my pivot point in this problem. Wow, that's a lot of P's one more time. So what I'm going to do is I'm going to group my two clockwise. So now I'm going to actually write out the answer for this problem. So I've got a force A, there's no angle, so the equation for it would be nothing but, let's see if I can get this in here. That would be A times the radius. How far is A from the pivot point? Well, there's 1, there's 2, 3. So it'd be A times 3. There's my pivot point. I'm going to add my other clockwise. Well, this C is at an angle. So I need to make sure for it I write C sine 40. And it's at a distance of 1 meter from the pivot point. So I'm going to add to it C sine 40. And once again, it was a distance of 1 from the pivot point. And now I'll go back. This one was counterclockwise. So I'm going to subtract it. I'm going to write minus for this next one. And now if I look, it's at an angle as well. So I'm going to write minus B. I'm going to write sine again, sine of 30. And now all I know is how far is B from the pivot point. Well, this is my pivot point. So I've got 1, 2. Equals. Now, this is what you would call a sum of the torques question. I've done a sum of the torques because I've got multiple torques. But the general idea here is that what have I done? All I've done is FR, FR, FR. And the only catch is since these had angles, I threw in the sine function into each one of these to account for the angles. But it's just F's and R's. And I subtracted the counterclockwise from them. Now, there's two basic types of torque questions. The types that make you do this and you actually get an answer here. So they'll give you all these numbers. And then the second type is an equilibrium question. And they will give you all this stuff, but then tell you to set it equal to 0 in an equilibrium question. But anyway, so that's kind of got you an idea. Well, let's go back and do something. I'm going to go back and I'm going to mark out all my little clockwise and counterclockwise. Because here's the thing. You can pick any one of these spots to be a pivot point. So now what I would like you to do, and I'm going to mark on it this time, let's pick this guy to be my pivot point. And this is the way I normally do it. I like to circle my pivot point. So you, sir, have just become my pivot point, which means I have just canceled this B out. So in other words, this force B, since it's the pivot point, has absolutely no bearing in this torque question. So I've chosen it to be my pivot point. Well, let's go through and do something here. I'm going to break out my trusty ruler again. Stick my finger at the pivot point. And now I'm going to push up at A. Well, that's going up. So this is still a clockwise torque. Put my finger back down here. We'll try this finger. C, I'm going to push. And C, apparently, if I push at C, oh, that's a counterclockwise torque now. So he's counterclockwise. And let's try one more thing. Let's go over here to D. And let's push D. Well, D is also a counterclockwise torque. Now, let's look at this E. Let's try and push. Boy, I've got some wicked light going here. Oh, well, wow, I can kick my own light. But, wow, that sucks. If I push at E, pushing this way, wait a second. This is not even a torque. E is not a torque. E has no bearing in this problem. E is exactly horizontal to the beam. Therefore, there is no angle. Therefore, this force E does not have a torque. So, a lot of problems try and do this. They'll give you something that's horizontal. In other words, a force that's with the beam. Well, if you've got a force that's actually running in the same direction as the beam, there is, basically that force has absolute, I could actually go in here and just pretty much mark that one out, because it's not doing anything in terms of my torque question. Now later on, the hard problems, you got to do some of the forces X and some of the forces Y. So you'll actually use that as part of your problem. But for this one, let's just go down and let's see if we can't do this now. Let's do a sum of the torques based upon that pivot point. So I'm going to write down my clockwise, then subtract my counterclockwise. So sum of the torques. Clockwise, I've got an A, and how far is A from my pivot point? Well, from A to my pivot point is 1 meter. So I've got A times 1. And now, the rest of these torques are counter, so I'm going to subtract them. So I'm going to write minus. So minus C sine 40. And now, how far is C from the pivot point? Well, it's 1. So I'm going to write times 1. And then I'm going to write minus again, because this other force is also counterclockwise. So minus D. And I don't need a sign, because D, if you look in the picture, D is perpendicular. So D, now how far is D from the pivot point? Well, D appears to be 2 meters away. And bam. And sometimes they'll give you numbers, you'll do that, or you'll set them equal to 0. It just depends on the question. But anyway, this is the basic, usually the first questions in the chapter just want you writing equations like this out. And that's kind of what we've done here in that one. I've actually got one of the textbook questions here, and let's take a look at it. Although I'll be honest, I hate how small they draw this out. So I'm probably, if I got room, I'm going to try and draw out a much, much more massive version of this question. So let's take a look at it here. So here's the picture it's given us. It's telling us that this thing is of length L. It's got us an angle in here. That's all right. We'll write that angle out. So I'm going to see if I can't copy that picture down. So there, you take a look and you copy it, but you draw it big, because that's exactly what I'm going to do. Go hard or go home. So I'm going to draw me a really big version of what we see in that picture. Let's see. Draw me a great big old beam. So there's my beam, a little bit larger than what's in that picture. And now I'm going to go through and label it like that picture. Let's see, it's got a dot here. And I like to make sure and emphasize those dots. And it's telling me I've got an Fx, it's saying here. It's saying you've got an Fy. And here, what's funny is this. You're really learning the physics of the chapter in these first problems. Looks like we've got dead in the middle. Almost wishing I drew it even bigger. Looks like we've got an FG. Oh, it even went calculus style. It gave us a little arrow right there above it. And then let's come over here. We got another spot. It's saying that there is an RY and an RX in this problem. Now, let's see. It's also coming back, a little random information. And it's telling me that this whole thing is of length L. And it's saying that there's an angle of theta down here. So there's some interesting information in this problem. So, I wonder what it wants us to do. It says, and I'm going to scroll down so we can see this, write the necessary equations of equilibrium. So this one's saying equilibrium. And what this magic equilibrium word's telling me, I'm going to write sum of all my torques. I'm going to set it equal to 0 in this problem. Take the origin of the torque about an axis perpendicular to point O. So it's telling me, hey kid, pick this spot to be my pivot point. Well, that's fabulous. I love picking that spot to be my pivot point. The reason why I would have picked that point to be my pivot point anyway, your pivot point cancels everything out at the pivot point, which means by making this the pivot point, I just canceled Ry and Rx out of my torque problem. So I just got rid of those. So now I've got 1, 2, I've got 3. So I'm going to have 3. Well, I need to go through, before I do anything else, I need to do something. I know that this is L away, and I know that this would then be L over 2 away. So I've kind of got my radiuses figured out. Both of these are L, and that one's L over 2 from this pivot point down here at the bottom. I need to go ahead and get some angles here, because we take a look at this, and we can tell we've got some angles. Well, if you know anything about trig, and boy, this is where I wish I would draw mine bigger. I'm going to have to write small. That this angle up here would be theta minus, or excuse me, 90 minus theta. Wow, you can't read that at deadgum all. But anyway, that angle is, here, I'll write it over to the side. The angle for that one would be 90 minus theta. Because whatever this angle is going to be 90 minus that theta. Now let's go back up to the top. See if we can decipher these angles. Well, let's see. If this is theta, then that means at the top, that's theta, which means this other angle is, and dadgummit, we're in that same spot again. If that's theta, that angle is, I'll write it over here, that angle is also 90 minus theta. So it'd be nice if we had some numbers here, but instead we're just stuck with what we got. So if that's theta, that one's 90 minus theta. If that is theta, then that angle is also theta, and that angle is 90 minus theta. Now for that fun game. Clockwise or counterclockwise. So I'll stick my finger at the pivot point. And now we'll push down where FG is. So push down. Push down at FG, and which direction? I'm rotating everything. You can tell I'm going clockwise. So FG, thank you FG. FG is clockwise. I like writing that on there just so I know which direction it's spinning. Now let's go back up here. Pivot point again. FX, let's see, if we push that direction, it looks like we're also going clockwise. And now one more, that FY. So I'm going to put my finger at the pivot point, and now I'm going to push up. And you can tell when I pushed up, she moved counterclockwise. And again, the reason why I do this is this. I want to add up all my clockwise, so I'm going to add the clockwise, and then I'm going to subtract the counterclockwise. So based on this pivot point, so I've got 2 clockwise. And now all I need to be thinking again is FR. And if there's an angle, I'll write F sine theta R. So let's see what we can do here in this equation, or this problem. I've got an FG sine of 90 minus theta, because that was the angle, times L over 2 plus, this is only, I've got 2 clockwises, so the FG was one, and now FX is the other one, so plus FX, it's at theta, FX sine theta times L, because it is L distance away from my pivot point. Now I'm going to write minus, I'm kind of running out of room on my paper, minus this counterclockwise, Mountain Dew lid, counterclockwise torque. Wow, 20-minute long video. I apologize, but torques are kind of tricky. So we're going to subtract this one now that we've got up here. So I'm going to write minus Fy sine of 90 minus theta. So minus Fy sine of 90 minus theta times the radius. And the radius is still L. So times L. I'm going to set all equal to 0 because it said it's equilibrium. But anyway, you have to understand this video which obviously you didn't skip it, but if you would have, the next videos mean absolutely garbage to you because you have no idea how to get all these torque equations. But anyway, the next video will actually do something practical with these. But thank you.